Okay, so hi everybody. Today's lesson is about acceleration. Acceleration is probably one of the harder topics that we're going to cover. It has some complications, which I'll explain as we go along. So let's start. Start again. Start with a pen and yellow. So acceleration. Now you know about acceleration when you're in the car and or someone else is driving, possibly not you, and they put their foot on the accelerator and they speed up. We call that acceleration. We also, actually, when we put our foot on the brake and we slow down, that is also acceleration. It's just in the opposite direction. So basically, acceleration is the rate of change of velocity over time. Okay, rate of change of velocity per unit time. Okay, so also a vector quantity, so we use the small arrow. So here's the formula. So in words first, average acceleration is equal to the change in velocity divided by the time. In symbols, acceleration is small a with a vector is equal to delta v on t. Delta just means change. I'll just use a different colour. So, don't know what happened there. Let's try that again. Pen, delta means change. So delta v means the change in velocity over time. I'll just go back to yellow. I should have a small there as well. So the change in velocity is the final velocity. So v final minus the initial velocity. And we write it like that. Right, so we can rewrite this now as v subscript v f minus v subscript I over time. Now, these are quite cumbersome, so physicists have actually come up with a new way of defining these. So we actually call the initial velocity as a different symbol. We use u, and the final velocity we call v. So we can now rewrite this finally in its most user-friendly form is v minus u over t. Okay, phew, finally got there. The units for acceleration, so let's put them over here. The units are meters per second, which is the velocity part on the top here, over seconds, which ends up being meters per second squared. So if you look at it this way, it's easier. This way here is actually easy to get your head around. It's the change in the velocity per second. Okay, so we'll do a couple of worked examples and we'll see if we can figure out how to do this. So I'm going to change page. Okay, I'm going to change colour. Go orange. Okay, so we've got a situation. We're going to question 1. So we're going to start from rest and accelerate to 15 meters per second over a time of 5 seconds. Okay, so we want to find what is the acceleration. Okay, so we want to find the acceleration if we go from 0 or from rest to travelling 15 metres per second, and it takes us 5 seconds to get there. That's what we're asking. So we write out the formula first. Very important we do that. Equals V minus U on T. And then we write down over to the side here everything we know. So we know that the initial velocity, or U, is 0 metres per second because we started from rest. Rest means we're not moving. V, our final velocity, that's the velocity that we reach after 5 seconds, which was 15 metres per second. And the time it took us to get there was 5 seconds. And all our units are okay, metres per second and seconds is correct. So all we have to do is substitute them in. And be careful with negative numbers here. We'll get to some harder ones later. Okay, so our final velocity V is 15 minus 0 over 5 is 15 over 5, which is 3 metres per second squared. So what this means is that our speed is increasing, okay, by 3 metres per second every second. That's what it means. Okay, I'll change colour. We'll do another question. Let's go green. So question 2, this time we're going to be, we're travelling at 20 metres per second, and then we're going to slow down to a stop. Right, slow down to a stop, which takes 10 seconds. Okay, so we're travelling along and at 20 metres per second, and then we say, oh, I've got to slow down, and I start putting my foot on the brake and I slow down until I'm eventually stopped, and it takes me 10 seconds to slow down. So what's our acceleration now? So let's write our formula again. Equals V minus U on T. This time, our U, or our initial velocity, is 20 metres per second. And our final velocity, V, is 0 because we've come to a stop, and the time it takes us to do it is 10 seconds. So if we substitute all those in here, V is 0 minus 20 over 10. So I get negative 20 on 10, which is negative 2 metres per second squared. Now this is interesting, isn't it? We've got a negative number here, whereas up here we had a positive number. I'll just change colour again, at a positive number here, okay? So a positive number means that our acceleration is in the same direction as our velocity, okay? This is the thing we normally, it's speeding up. What we normally call accelerating, that's what we mean, speeding up. However, whoops, this is in the road. This one here, 2 metres or negative 2 metres per second, this means we're slowing down, okay? So if it's negative, or if the acceleration is in the opposite direction to the velocity, that means we're slowing down. Okay, should we do, no, we won't do another one. I might leave it there, and we'll stop it there, and you can do some practice now.